what we've seen in the public address market is things moving more towards IP, right? We've seen people say, hey, we're going to a network solution, so we want to put amplifiers in remote locations, distribute them around a facility, distribute them in other buildings on a campus. People want a better user experience. How many times have you walked in and you've seen just the old call station with a button and a piece of paper and a label next to it, and you really have no idea what it's doing, when it's time to talk or whatever. So you'll see how we've kind of improved user experience, feedback, giving you actually letting you know, okay, now it's time to talk, etc. Green, that's just more energy efficient, right? We've kind of redesigned some amplifiers, and we'll look at that a little bit. And then again, efficiency from a rack saving standpoint of, hey, we're trying to put more in smaller places to reduce the footprint. So where does PA work, right? Well, we refer to public address. Pretty much any building where you want to have audio, right? Whether it's used for paging, whether it's used for mass notification, whether it's used for background music, whether it's used for just scheduled events, scheduled announcements, right? All of these different things. And what we've done is given you the ability to use all of those different things or any piece of those in one platform. So in the past, this is kind of the portfolio that we've had, right? We had Presensa living here. This is what we've talked about before. A few years ago, we talked about Paviro and then Plena on the bottom line. And there was kind of this gap, as you see in the middle. And with that, we've actually had some changes. We've actually expanded the Presensa portfolio because we're really building on that platform. And that's more building in the IP. So when you look at that, we've actually introduced Presensa at the small scale as well as Presensa above the 500 zone count that it already was in the large to a multi-large site or multi-controllers. So looking at it, what is it? How does it work? We look at it from an IP perspective first. And it's a full list of components here, but we really said, hey, we want to keep the design count small, right? We don't want all of these different amplifiers. We don't want different power supplies. We don't want different controllers, different call stations. So we really manage the SKU list. So when you look at it, you're going to see, okay, we have a call station, whether it's a wall mount one with a cable microphone or a gooseneck. So you got an option there. You'll see, okay, there's a controller at the top, and then there's two amplifiers, and then the power supply. And we'll talk about these a little bit more. But just to kind of give you a perspective of where we came from, right? We came from a world where we had 4 different amplifiers in the Presidio portfolio, right? They were 4x125, 2x250, 8x60, 1x500, right? We had them also in 3 different versions, basic, power. We had them in 3 different country voltages, right? And we really said, okay, this is just not sustainable, right? Both from an integrator standpoint and from a design standpoint, and as well for the end user, because you never had the right one spare if, heaven forbid, you had a failure. So what you'll see is we took this down and we said, all right, we're going to design this where it's simple, it's compact, but yet it's easy to be able to be scaled up. And we'll look at that a little bit more. With moving into the network, encryption is important. So we use AES-128 encryption for the audio, and then TLS encryption for the transport layer for the control. So all the security is built in from that standpoint in the system. It is a networkable device. It is completely encrypted. You can define your own encryption keys if you want. And that's for all the communication. So that's coming in from the power supplies, that's going to the amplifiers, that's going to the call stations as well as the controller. And you might wonder, okay, what if I bring in audio from a third-party device? Or what if I'm bringing audio in potentially over SIP? That's fine. Once it hits the Presensa system, it is completely encrypted. So now we're encrypting it if we're being given unencrypted audio at the head end and distributing that out encrypted. Looking at this, we talked about rack and space saving. So what you see there on the top or the image, the stack of amplifiers, this is the Presidio amplifiers. Everything was 2 rack spaces no matter what. So we reduced that in half. So now we've taken what used to be a 500 watt amplifier, we've added power to it. So we've also added additional power, so it's 600 watts, and bringing that down to a half space. Now, to take that even further on the Presidio side, if I wanted redundancy, I needed 4 of those, 4 rack spaces to be able to do that. And in Presensa, we've built the redundancy in the single rack space already, and we'll talk about that a little bit more. So when you look at the amplifiers, right, what you'll see here is the top is showing an image. Think of this as your fuel tank. Yeah, an amplifier itself has 600 watts. What the amplifier does is distributes that power across whatever's connected to it. So if you say, okay, if I'm using 300 watts out of channel 1, then I have 300 watts remaining that I can use on 2, 3, and 4. So this gives us less waste, right, when we design a facility or we design a system. So if we're using a whole bunch of small zones, maybe we're going to use the 8-channel amplifier. It's still 600 watts over the 4-channel, so giving us this flexible power to be able to do that. I mean, I'm guilty of it as well, right? We've said, hey, we have a 2x250 watt amplifier. I needed 175 watts to cover this room, for an example. I'd use that 2x250, and I might use that other spare channel to put 3 watts on, right, in an office or a restroom. So this is really giving us the ability to not waste power, going more towards that green side. Highest system availability. With the Persensa system, we have UL listed this for UL 2572 and UL 864. So both of them being certified. And with that, we wanted no single point of failure. So when you look at this, you're going to see that there's a lot of redundancy built into the Persensa system. So with all the devices being networked, right, they're all out on the network. We're always ensuring that they're being supervised. So we're always checking for that system, that component, to be able to always be there. UL says, hey, from that standpoint, you need to find that every 200 seconds and ensure that it's operational and it's communicating. We actually reduce that, and we guarantee that that'll be supervised within 30 seconds. We do it much faster, even to the point that UL says, yeah, you do it a little bit too fast at times, but we always want to ensure that system's operational because a lot of things are being used in mission-critical applications. We talked about this a little bit from the amplifier standpoint. But as you can see here, we're showing that we have those 4 amplifier channels, but there's a spare amplifier channel sitting inside that amplifier. So if you were to open the lid of a 4-channel amplifier, you're actually going to see a 5th channel in there. If you open an 8-channel amplifier, you're going to see there's a 9th channel in there. And that amplifier channel will take over automatically in the event that an amplifier channel was to fail. So now we're giving you primary and secondary amplifier channels in the event that an amplifier channel was to fail. We also have dual Ethernet ports. So there's a primary and secondary Ethernet port on every device. So when you look at that, however you want to design that on the network, if you want to do it as an RSTP loop and daisy chain them all the way back around, or if you want to truly home runs back to a switch, you have that flexibility. Every device has a primary and secondary power supply if it is not PoE powered, as well as we do have battery backup connections directly on the multifunction power supplies. So here's kind of an image of what that looks like, and when you look at it, you see we've got the redundant DC connections coming down. You've got the system controller, the amplifier, all being powered by that MPS, and then as well as it having the main and backup power. So the user experience, right, this was a big piece. You know, there's a lot of times where you can say, okay, I can train 1 or 2 security personnel on how to use this. But what we're finding is they're using it a lot more for business applications. So whether this is sitting at front desk for reception, whether it's right a gate agent at an airport, these type of applications where you're really not going to train, you don't have time to train, you have people moving around from time to time in different places. You want something that's easy to use. When can I make an announcement? Is the system broken? And what we said is, okay, we want all of that to be right on the screen. So when you look at that, you're going to see user feedback, right? You're going to see where it says, okay, you can talk now. It was successfully delivered. It'll also tell you if an area was broken, that it might not have been delivered, right? That there was a zone or something that could not have been delivered from that standpoint. Or if somebody else is talking in that zone, maybe there's a life safety or mass notification event and I don't have a high enough priority to override or talk into that area because I'm being overridden by an alarm, that could also be displayed. Kind of some system designs just to kind of show you what this looks like a little bit here. On a distributed PA system, right? Being able to put different pieces in different parts. So top left, we're kind of showing, okay, this could be a main head-end. This could have your controller, your amplifiers. We got 2 amplifiers and a power supply all living in one system. But then if we have satellite locations being distributed around, and it's showing us also the different type of redundancy. So if you come down the left-hand side, you're going to see we have speaker lines connected there. There's 2 ceiling speakers, 2 rows coming out of that with these little teeny little red cards on the end. We call those end-of-line supervision cards. What does that mean? That goes on the end of line of the last speaker, and it's a heartbeat that the amplifier looks for constantly and ensure that speaker line is always connected. Doesn't need to be a Bosch speaker, it can be any 70 volt speaker, any 70 volt line. Put this little card on the end of it, and I'm going to let you know for some reason if I lose that card. If you look at the middle one and the far right one, you'll see as well we support Class A loops on the speaker lines. So if you're really worried about, okay, something that could get cut, you can do the speaker lines, Class A loop, bring it all the way back around. We're still going to report a fault if for some reason it gets cut, but it is more likely to stay operational versus the top one. If it gets cut somewhere, you're going to lose everything down line, and we're just going to report that as a fault. Here's kind of a larger system approach. I kind of threw this in just to really show, okay, this is how we scaled up, right? In the past, we had these small system clusters that were individual, which you have on the bottom row. They could be different locations, different buildings, etc. But we've also added in this, what we call this control room approach, and that's coming from the top right corner. With this, you have the flexibility of control of how you actually want to make announcements. So let's take each one of the locations, for example. They can make pages in their announcements, but they're being overridden if anything comes down from the main control room or main operations. You also have the ability to say if you want a sublocation to be able to talk to another sublocation, right? Sometimes it doesn't make sense for building A to ever make an announcement in building B, but it would make sense from like a campus lockdown to come down from above. So you have that flexibility. Again, it all goes back into that priority. And then, you know, with the PA system, being that it is IP, can put that on layer 3, can jump different subnets if we need to, all of that fun stuff now in the larger scalable solutions. So like we talked about, kind of some of the key takeaways there, that it is IP, you know, the architecture being that it's flexible, giving us the ability to distribute amplifier channels as needed. From a 25, 72, and 864 standpoint, that part is important. As well as, like we said, that new user feedback from that standpoint. Some of the interface options, you know, as we move into IP, as we heard this morning, kind of in the intrusion side as well as video, sensors in the field are becoming a lot smarter. We want to do other things with them, and that also comes back into the IP side of the PA system. So when you look at this, we said, okay, we want to do an API, we want to interface, we want to have all of these different commands, but we want to keep it encrypted, right? That's important. So with this, we've actually come up with what we call the intelligent control. So this gives us the ability to bring in events and be able to trigger messages, whether that's somebody coming up to an area that, you know, they shouldn't be at, right? If we're doing perimeter security, maybe it's a welcome message because somebody comes into an area in a retail operating hours. Somebody, you know, comes on to a playground or a ball field at a school after hours, right? It's okay, right? They can play there, but then at sunrise or sunset, maybe we want to play a different message. So giving us that flexibility and to be able to schedule these different things, whether that's coming from an OnVIF device, whether it's coming in via MQTT, whether it's something coming from a B series or G series panel, we have the ability to bring all that in and do sensor detections for PA. So kind of as Matt said before, you guys know your business the best and what works and what you need. So if you have some ideas or something you want to brainstorm, feel free for sure to bring it up and we can discuss that. The Presenza family members, we've kind of discussed this in the past. You know, really a small list of devices in the portfolio, right? We wanted this to be able to be flexible, but we didn't want to have a lot of different components, both from a design standpoint, from a maintenance standpoint of the system. But what I want to do is highlight some of these new ones. These are what's new since we were here last year. So we do have that system controller small, which is important. This allows us to now do smaller solutions more cost effectively. We do have what we call the Arnie E and the Arnie S. This is going into that enterprise platform, being able to bridge different subnets. We introduced an IP wall controller, what we call the wall control panel here. That's a PoE volume control that can go on a wall. So if you have a room like this, for an example, where they're using it for paging or they're playing background music during the day, they can just have a control panel, turn the music off in this room for something like this, and then turn it back up as needed. 16 by 8 interface module for GPIOs, as well as the Pixie Core Edge controller. So looking at these, right, the small system controller looks exactly like the system controller large. Nothing has changed there other than the system controller has a little bit smaller board in it and supports up to 6 amplifiers. Right, so really scaling it down for those cost-effective solutions. So if you say, hey, I have one MPS, 3 amplifiers in one location, and then I have another one and 3 amplifiers in another, that's what the system controller small is designed for. Still gives you all of the options where you can say, hey, I'm going to connect to the API, I'm going to do all of that, but it really has that limited zone count. The 16 by 8 GPIO interface here. So with the different inputs and outputs, so you'll see the 16 inputs there in the middle row, and then the 8 outputs there on the right-hand side. There are also 2, an A and a B, underneath that 16.8 on the output sides that are actually NAC, so 12-volt supervised circuits, to be able to use that directly for activating NACs as well as keeping the supervision from that standpoint. With this, it is a PoE GPIO unit, which is nice again. So if we've got Presenza in one location, we have a whole relay cluster somewhere else or a fire panel that we want to interface with in another location, we can take this device directly out there over Ethernet, still being supervised over the Ethernet, still certified, as well as having the inputs and outputs. All of the inputs are also supervised on this from that standpoint. Here's a little look at that wall controller we talked about before. So you can see just a standard wall controller with a volume control knob on the front of it. Depending on the environment, you can have a pin code to unlock the volume control, as well as be able to turn that volume up and down or select different music streams if you've got different music streams coming into the system. And then the ambient noise sensor. We talked about the ambient noise sensors just from a kind of a key intro last year. But what I wanted to bring up here on the ambient noise sensors, that they are now certified. They are finishing up in the UL and they're ISO 7240-16 certified. So with this device, I think what's important to realize and refresh everybody's memory on, it is not a microphone. When we say ambient noise sensor, it's a true MEMS sensor. So it's not like somebody, if I have this in an environment, can go listen into this device or hear what's going on. There's not a true microphone. It is a MEMS sensor looking for SPL or sound pressure level in the room, and then it is only sending IP commands back to the amplifiers to be able to adjust based on ambient noise. Any questions on Presenza? Yes. Yep. So the GPIOs are supervised. So the question is, how are the GPIOs supervised? Standard, just end-of-line resistor on the end of that.
Married to Dante.
Correct.
The new standard.
Correct. Yep. So we are married to Dante from the, let's say, the network audio of devices coming in from that standpoint. So if you say, hey, I want to give me a Dante stream. For anybody that doesn't know Dante, that's kind of like an OnVIF stream of video, but no audio format, or SIP on a phone side, right? It's a standard. It's an open. Multiple manufacturers use that. We do have SIP. We do use Dante. We do support OCA. And then as well as we will have an analog GPIO interface coming here later in November that'll have an analog input as well to bring audio in. Any other questions?
Is it UL
listed? Yep. UL 864. 864. Yep. So Presenza is UL 864 and UL 2572 for mass notification.
Okay.
That's where you need to use the Class A, right? Why?
That depends locally on the jurisdiction. Yep. With that, on the Class A loops, so on the network side, yes. I would say that's probably 98% say yes on that one. On the speaker side, that's hit or miss. And then if you like go to New York, for an example, they have a special key that you have to have on the first responder panel, whereas, you know, it's the same key for everywhere else in the country. So, you know, there's little nuances that come into play with that. One thing I will talk about, just because we're talking about the UL, is there are some options as well to go over fiber directly between power supplies, single mode and multi-mode. If for some reason you get into, let's say, a large warehouse and you're worried about network limitations and those types of things, you can do remote over SFP. We did release last year IP speaker portfolio. So you're seeing here that there's two different angles here. Just want to kind of give an update on that. One of which being the long throw, and then there's what we call the short or wide angle piece of that. There is a third version of the module. We call it a module itself. You've probably seen it out here in gun detection. They're triggering the message over the radios. What that's designed is, it's a module that just triggers audio. It's the same almost exact circuit board that's in the horn, except it's got an analog out to go into other devices or PA systems that aren't horns. When you look at this, right, it's really based on this if you see something, say something mentality, right? I'm kind of always a reaction, right? I kind of joke a little bit, I'm like the TSA. The camera's got to detect something, it's going to trigger something to me, right? Or something's coming from an intrusion panel, I'm going to say something. You're going to see something, I'm going to pick up the phone and call it and say something, right? That's kind of the way this IP speaker is designed, and that's the way it works. So when you look at this, right, I'm going to say most of the time you're going to see it paired with a camera or a group of cameras to be able to do something. So the left-hand side, the middle, right, that's all coming from the video world, which they talked about a little bit this morning. And then the right-hand side is where I'm going to come in to actually execute that message. We do have integration with Sepelia on the Genetec side with the IP horns platform. So being able to pick that up, being able to distribute messages, be able to make announcements from that standpoint, and be able to use the entire thing, you know, as an integrated solution in Security Center. And then we've also got it integrated into Milestone XProtect and Bosch, the BVMS, of course, from the OnViv platform. So really depending on how you want to leverage it, how you want to use that, there's multiple different ways. There's SIP to go into it from that standpoint as well. And then the SIP also has had an update since last year, and that's what we're showing here on the bottom row, is it now supports cloud PBX. So if you say, hey, I want to make this an extension up in the cloud because I don't have my SIP server on-prem, you have the ability to do that in the system. So, yes?
Do you have any speakers that are like for interior, for like flush mount? Or are they all horns?
On the IP side, that side, they are all horns today other than the module. If you go to the Persensa side, so when you look at the paging system, there's a whole plethora there of surface mount, ceiling mount, horns, explosion-proof speakers, all of that fun stuff in the 70-volt platform.